Once again, myself is M.Sadashiva, Assistant Professor in Chemistry, GBR College, Huvinadagli. It comes under VV Sangha, Veersagar Development Sangha, Bellary Institution is there. Now I will start BSc, the first sem continuation is there, that is part 2. That is the part 2 is there, that is called as oxidation reduction reactions. So here, the oxidation reduction reactions, so what is called a disproportion and calm proportion is there. Disproportion and a calm proportion. What is a disproportion? Means when any oxidizing compound, when you will be having any oxidizing compound like iron or the copper or the gold or the silver, whatever it may be, so it will be changes its oxidation states. It will be changes its oxidation state will be called as a disproportion. It will be called as a disproportion. Suppose for example, if we having the iron, we will be having one oxidation state is Fe plus 6. It will be changes to the Fe plus 3. Fe plus 3 will be changes to Fe plus 2. Fe plus 2 will be changes to what is called zero oxidation state. So this is called as a disproportion. This is called as a disproportion. Means when an iron metal will be having oxidation state is plus 6, changes to plus 3, plus 3 to plus 2, plus 2 to 0. So this is called as disproportionism. Then we will be having the copper Cu plus 2 will be changes to Cu plus 1 and it will be changes to the Cu plus 0. This is also called as example of what is called as a disproportion reactionism. That is proportion, the reactionism. Then we will be having the manganese, that is K-4. It will be having the plus 7 will be changes to the Mn plus 6. Then it will be changes to Mn plus 5. It will be changes to Mn plus 4. The Mn plus 3. And last is Mn plus 2. Like this is so these are all the reactions will be called as a disproportion reactions. So these disproportion reactions will be come across what is called as a representation of potential data is the representation of a potential data. So the representation of potential data means we will be come across the three types of diagrams. We will come across three types of diagrams, that is called as Latimer diagrams, the Frost diagrams, and the parabox diagrams. The first one will be called as Latimer diagrams. The first one will be called as Latimer diagrams. Latimer diagrams. The second one will be called as Frost diagrams. The Frost diagrams. And last one will be called as parabox. P-A-R-B-A-U-X, parabox diagrams. The parabox diagrams. So, the first of all, what is called as the Latimer diagrams, the second one is the Frost diagrams, and the third one is the parabox diagrams. So, Latimer diagrams can explain what is called the different oxidation states of metals or the non-metals. The oxidation states of different metals like iron, copper, or the non-metals. Any of the metals of the non-metals they can show different oxidation states. That is called as a Latimer diagrams. The first one is a Latimer diagrams. So, these Latimer diagrams, first of all, we can consider the best example is iron metal. So, the iron metal, it will be having the first oxidation state is Fe plus 6, will be changes to the Fe plus 3, Fe plus 3 will be changes to Fe plus 2, and finally it will be having Fe plus 4, the Fe plus 4. So, there are two conditions in this Latimer diagrams. This one is when an higher oxidation potentials, when an higher the oxidation numbers can be write down towards the left side of the reaction is there, and the lower oxidation state should be right towards the right side is there. Then the second one is this one is there. So that is called as the value of the standard electrode potential of volts will be in a horizontal line connecting these pieces. So now we can write down the one by one reaction is there. That is what is called as a Latimer diagrams. Now first one is a Latimer diagrams. So the Latimer diagrams of iron will be like this. The first one is what is called Fe plus 2 plus 2 electron. Fe plus 2 electron to form Fe a solid. Fe a solid. Its energy, that is e to the power of 0, is equal to what is called as a minus of 0.47 volts. Then we will be having the second equation is Fe plus 3 plus 3 electrons to form the Fe a solid. The Fe a solid, its energy is, this one is that is a minus of 0.051 volts, 0.057 volts. Then we will be having what is called as Fe. Then the third equation is Fe plus 3 plus 1 electron to form a compound Fe plus 2. So it's e to the power of 0 is equal to what is called as a plus of, it will be called as plus, sorry, the equal 0.77 volts. 0.77 volts. Then the next reaction is FeO4 minus 2 plus what is called as 3 electrons plus what is called as 8 of the H plus 8 of H plus gives rise to be the Fe plus 3 plus the 4H2O will be liberated. 4H2O will be liberated. Its liberation of a standard electrode potential is plus of the 2.20 volts. 2.20 volts. So here this is the first step is this one. This is the first reaction, this is second reaction, this is third reaction, and this is the fourth reaction. So these are all called as, comes under what is called as the Latimer diagrams. The Latimer diagrams. The Latimer diagrams, the first reaction is when an iron will be having oxidation state is Fe plus 2. Gains 2 electrons to form iron a solid metal. Its standard electrode potential is minus 0.47 volts. The second one is Fe plus 3, that is a ferric iron will be gains 3 electrons to form iron solid. It will be having a standard electrode potential is minus 0.057 volts. And the next is Fe plus 3 plus gains 1 electron. It forms Fe plus 2 ion. So e to the power of 0 is equal to the standard electrode potential is 0.77 volts. The last reaction is FeO4 minus 2 plus 3 electrons plus 8 is plus gives rise to Fe plus 3 plus 4 is 2 is the standard electrode potential is at 2.20 volts. At 2.20 volts. So on these reactions, that is the first reaction, second reaction, third reaction, the fourth reaction can be write down according to the Latimer equation is the first reaction is this one, the second is this one, third is this one, and fourth is this one. So that is called as a Latimer's diagram. That is called as a Latimer's diagram means the higher oxidation states can be written the first. Then it goes to next higher oxidation state, the next lower oxidation state, the next is lower oxidation state. That is called as a Latimer diagrams. That is called as a Latimer diagrams. Okay. So now you can write down this overall equation for the Latimer diagram. That is called as, the first equation is this one. FeO4. The FeO4 minus 2 gives rise to be, it will be having plus 2.20 volts to form the compound Fe plus 3. Fe plus 3 will be having 0.77 volts. That is Fe plus 2. Fe plus 2. Fe the plus 2. So this is 0.47 volts to get Fe, to get the Fe's. So here this can be converted into the Fe. It will be having the energy is plus of 0.057 volts. So this is all about what is called as a Latimer diagram. So Latimer diagram is, this is oxidation state of iron is 6, and this is 3, and this is oxidation state is 2, and this is oxidation state of iron is 0. So So that is the 6 oxidation state of iron changes to 3 plus 3, Fe plus 3, then Fe plus 3 will be changes to Fe plus 2, Fe plus 2 will be changes to 0. This is called as a Latimer diagram. This is called as a Latimer diagram. So from this Latimer diagram, we can write down the overall equation. We can write down the overall equation will be like this, sir. So that equation will be like this. Fe plus 3. Fe plus 3 plus 1 electron to get Fe plus 2. Then the Fe plus 2 plus 1 electron to form a compound plus 2 electron to form a iron. So here e to the power of 0 is equal to, that is 0.77 volts, and this one is e to the power of 0 is equal to the minus of 0.47 volts. So that is a delta G. Delta G to the power of 0 is equal to minus 2 into minus of 0.47 F into the F is. So that is delta G to the power of 0 is equal to minus of 0.94 F. 94 the F is. Then we will be having the first equation, delta G to the power of 0 is equal to, that is plus 1 into minus 1 into 1 plus 0.77 here. We can get it. Finally, the value is delta G to the power of 0. 0 is equal to plus of 0.77 F. Now we can write down the overall equation. That is the first equation is Fe plus 3, that is steady state of iron, gains 1 electron to form Fe plus 2 is there. Its standard electron potential is 0.77 volts, and delta 0, that is free energy, is minus 1 into 1.1 plus the 0.77 F. That is final answer is delta G 0. Delta G to the power of 0 is equal to plus of 0.77 F is there. Then we will be having Fe plus 2, that is